for joining Gwinnett County Public Library for our Meet the Author series discussion with Dr. Joe Schwarcz. The author's newest book is Science Goes Viral, Captivating Accounts of Science in Everyday Life. My name is Denise Osier, and I'm with Gwinnett County Public Library's Adult Services Department. Now I'd like to introduce our doctor coming to us from Canada. We're very grateful to have him. Dr. Joe Schwarcz is the director of McGill University's Office of Science and Society, dedicated to demystifying science and separating sense from nonsense. He is a very popular lecturer, both to students and to the public at large. And he hosts the Dr. Joe Show on Montreal Radio. And on top of all of that, in his spare time, he is the author of 17 best-selling titles. He lives in Montreal, Quebec. We welcome you, Dr. Joe.
Thank you very much. It's a pleasure to address this audience. And as you heard, I am a professor of chemistry, so let me start with a professorial story for you. One day, a professor was speaking to a large class, and he wanted to have an impact. So he made a demonstration. He goes over to the side of the lecture room, and he picked up a bottle with a living, live worm in it. And he poured in a little bit of tobacco juice, and the worm died. He did it again with a little bit of chocolate syrup, and the worm died. And once more with a little bit of alcohol. And once again, the worm died. He then asked the students, "What do you make of that?" And one student in the back started waving his hand, and he said, Sir, I know. If you drink, smoke, and eat chocolate, you don't have to worry about worms." Well, the fact is that he had made the right observation, but he came to the wrong conclusion. And science is all about making observations and coming to a conclusion. And that really is what we deal with through my office here at McGill. We try to separate sense from nonsense. And as you can imagine these days, that is a very, very challenging endeavor. We do this without any conflict of interest. We do not accept any money from any vested source. Our only allegiance is to the scientific method. It makes no difference to me or my staff whether or not any drug, cosmetic, food additive is regulated or not. The only thing that matters is that whatever decision is arrived at based on proper scientific methodology, not on hearsay and not on emotion. Of course, science basically starts in the lab. However, it is really not of much value until fellow researchers and the public learn about what is being done. So communicating science, which is what we really emphasize, is a very important specialty in science, because doing the work is meaningless unless it is put to some use, and the only way it can be put to use is by disseminating information. Unfortunately, these days, there's a lot of disseminating of information in an improper way. This is the era of information, but it's also the era of disinformation and misinformation. There are all kinds of people standing on soapboxes out there, making all sorts of claims without having any relevant background. These are what we call the quacks, and they can be very, very convincing. They have learned to cloak themselves in the garb of science. They have learned to spout pseudoscientific lingo, and they're becoming bigger to reason with them and to upturn their cockamamie ideas. They are everywhere. They are multiplying like rabbits. And we in the scientific world feel that we are in the way of a tsunami of misinformation. Now, of course, there's just a tremendous amount of information out there, thanks to the internet. But trying to make reason out of the information that is available is like trying to drink from a fire hydrant. It's very difficult. It's very difficult to separate the facts from the myths, unless, of course, you have some solid background in science. And this is especially true these days, when the world, of course, as we know, over the last year was practically closed down due to this plague of the virus. And of course, when science doesn't have all the answers, and certainly with COVID, we don't have all the answers, that's when the quacks rush in with their miracle cures. Where science leaves a vacuum, they will rush in. Now, there's nothing new about this. Snake oil has been around for a long time. If we go back to the 1800s, snake oil was widely promoted as being a remedy for arthritis. Why? Because snakes were supple, they curved all over the place, didn't suffer from arthritis, they were lubricated from the inside. So the belief was that if we could just isolate whatever lubricated them, we could use that. Of course, snake oil didn't really have any sort of therapeutic effect, except if you believed in it. The placebo effect, of course, can be very powerful. Well, today, we don't sell snake oil, at least not called snake oil. We call it many other things. Colloidal silver would be one, such as promoted by Alex Jones, one of the great proponents of misinformation on the web, or Joe Mercola, who, according to the New York Times, is the #1 spreader of misinformation in North America. Now, he is actually an educated person. He's a former osteopathic doctor who, of course, should know better. And the fact is that he probably does know better. However, he has also found the pot of gold at the end of the rainbow. And there's a lot of money to be made by hyping all kinds of supplements and claiming that they are beneficial for all kinds of conditions, including COVID. But then, of course, you have a lot of people who just spread misinformation, who have no scientific knowledge whatsoever. For example, not long ago, there was a debate about masks in Florida, and this lady testified saying that she doesn't wear the mask for the same reason that she doesn't wear underwear, because your body got to breathe. I don't think that's a very scientific argument. But what is really noteworthy, that you do have educated people, such as these doctors who call themselves America's frontline doctors, who have bought into all kinds of pseudoscience, such as hydroxychloroquine, ivermectin, homeopathic remedies for COVID. Now, they don't have a huge reach, although they have made a lot of noise, more than they should have made. But what happens is that some celebrities will buy into this, and they do have a large platform. Madonna, for example, thinks that Stella Emanuel, the lady that we just met there, who believes in aliens and all kinds of other silliness, Madonna thinks that she's on track. And then we have Woody Harrelson, very good actor, you remember him from Cheers, who thinks that COVID is caused by 5G networks. And a couple of weeks ago, we had Nicki Minaj, who heard from a cousin's friend about swollen testicles that somebody got just after the vaccine. And of course, the insinuation is that it was because of the vaccine. And then we have the worshippers of ivermectin. This is one of those remedies that has rushed in to fill the vacuum. Now, they talk about the fact that this was a Nobel Prize winning substance, which is true, because ivermectin is excellent at getting rid of parasites. That is what the inventor received the Nobel Prize for. However, when we look at ivermectin being taken by humans, that's a totally different story. Now, there are some reasons whereby humans, of course, can be taking ivermectin, and that's because humans can suffer from parasites. So let me show you again one of these cases where some vigorous blogger has suggested that ivermectin is being withheld from the public. And here's what they have said, that it is actually being given to Afghani refugees, but it is not allowed for the American public. And of course, the suggestion here is that these refugees are being given that to protect them against COVID, which of course is not the case at all. They are being given the ivermectin not as a protection against COVID, but because they were suffering from parasites. However, due to this kind of disinformation, uh, animal veterinary stores have sold out ivermectin. People are using doses for animals on themselves. And the FDA, of course, has had to come out with notices about this. We, of course, look at the science, and the science tells us that ivermectin just does not work. And, I wish I could tell you that it does. I wish I could say that, because there's nothing more that we would like in the scientific community than to come up with answers for these problems. But unfortunately, it just does not. I'd be the first one to push it if the evidence were there. People have also suggested the use of homeopathic remedies against COVID. We don't have the time here to really go into homeopathy, but I can tell you that it is the most absurd of all of the alternative methodologies there, because it is based on taking a substance and diluting it, to the extent that there's not a single molecule of the original left. The original, in any case, was never proven to have any effect anyway, so certainly not a diluted version of it. So all you're getting is just water, although that water has a good dose of placebo built into it, because there's a very strong connection between the body and the mind. However, while a placebo can make you feel better about your symptoms, the placebo does not cure a viral infection. Neither does chlorine dioxide. Now, the reason I mention this is because this also has been hyped as a treatment for COVID. It is purchasable on the internet, and also people sell it privately. It's called Miracle Mineral Solution. And you have two bottles, you mix these together, and it forms chlorine dioxide, which is a commercial bleach. It is used as an industrial bleach. But the claim here is that it can rid your body of the COVID virus. And this is the story, apparently, that former President Trump heard before he suggested, much to the consternation of the doctors who were present, that it might be possible to use intravenous bleach to rid our body of the virus. And in fact, people took this seriously after he, of course, said that he had been joking. But if you look at the video, of course, he wasn't joking. But the manufacturers of these substances had to take out ads to say that you should not use internal bleach to try to rid your body of the virus. Now, how can I say these things with so much confidence? I think it is because of my background in chemistry. Now, chemistry, to me, is the central science. It is the one that ties all the other sciences together. It is defined as the study of matter and the changes that matter undergoes. And everything that has mass and occupies space is matter. The world is made up of matter. So everything falls into the realm of chemistry. Unfortunately, chemistry doesn't have the best image. People think that chemists are these uncaring people locked away in a laboratory somewhere, just thinking about what new cancer-causing additive they can unleash on the unsuspecting public. They sometimes think that we are a totally different breed from others. But where do they get these ideas? From reading books like this, The Body Toxic, How the Hazardous Chemistry of Everyday Things Threatens Our Health and Well-Being. This portrays chemistry as the work of the devil, which it is not. To me, chemistry should be in the limelight because, as I said, everything in our life, everything in the world depends on what molecules can or cannot do. And there are no good or bad chemicals. There are only safe or dangerous ways to use them. And that is an extremely important point. Chemicals are not to be feared, neither are they to be worshipped. They are to be understood. Let me give you an example. One of the most widely used chemicals in the world is aspirin. It has been around since 1897, when it was first synthesized by Felix Hoffmann, a chemist at the Bayer Company, who was also the first chemist to synthesize heroin. Now, in those days, heroin was thought to be an excellent remedy for coughs, and it was sold along with aspirin. But anyway, back to aspirin. Aspirin reduced fever, it reduced inflammation, it was good against pain. This was in the very early days of drug development. And it was assumed that because it was good for all these things, it must be good for whatever ails you. And therein lies an interesting story, a story about hemophilia, which is the royal disease. Queen Victoria was a carrier of the hemophilia gene, although she herself did not suffer from the disease. But she did pass it on to her granddaughter, Empress Alexandra, who married the Russian Tsar. Now, she was also a carrier. She did not have the disease, but unfortunately, her son, Alexei Nikolaevich, did suffer from hemophilia. Now, hemophilia, of course, can be a very, very terrible problem, because it means that if you get the slightest bleed, you can't stop it, and you can literally bleed to death. Well, this connects with the amazing story of Rasputin, the so-called mad monk, who was greatly in favor with the Tsarina. How come? Because he helped her with the suffering of her son in a very simple way. He didn't believe in drugs at all. He believed basically in close contact with people, sometimes very close contact with his female worshippers. But anyway, he gave her the advice to stop the use of aspirin on her son. And that was great advice, because the last thing you want is aspirin when you're a hemophiliac. Aspirin has an anti-clotting effect, which is the reason that it is given to people who have had a heart attack to try to prevent a second heart attack due to a blood clot. So is aspirin a good drug or a bad one? It depends. If you have a fever, very good, will reduce the fever. If you're a hemophiliac, no, it can kill you. So what's our determination about aspirin? It is just a substance. It is a question of how you use it. So this is the kind of stuff that I deal with on a regular basis, especially on my radio show. I have a radio show that I do every Sunday from 3 to 4 Eastern time. In fact, you can tune into it anywhere in the world. You just go to cjad.com. CJAD is the radio station where I do this. And I've been doing this for 42 years. It is the longest running radio show on chemistry in the history of the world, although I suspect it probably is the only radio show on chemistry. So, I can cherry pick data with the best of them. But I deal with all kinds of issues. For example, not long ago, I was asked the question, is tripolyphosphate a chemical? And of course, as soon as I hear that, I know where this conversation is heading, because I know what the caller wants to know. Caller wants to know whether or not tripolyphosphate was one of these dastardly chemicals produced by an evil chemist in a laboratory or not. Well, she had been reading the list of ingredients in a cleaning agent, actually a pretty good cleaning agent, and she had crossed swords with sodium tripolyphosphate. Well, it's a term that I guess she found difficult to pronounce. And, there's this thing going around on the internet that if you can't pronounce it, you shouldn't be using it. So she wanted to know if it was a chemical, because to her, the word chemical was synonymous with poison or toxin. So, of course, I go into my usual explanation that everything in the world is made of chemicals. They're not good or bad, etc. And I explained that in this case, it is performing an important function. It is tying up the minerals in the water, which otherwise would interfere with the activity of the detergent. And I guess she bought the argument okay, because if you expect to find chemicals somewhere, it's in cleaning agents. That's where they belong. She calls me again 2 weeks later. I recognize her voice, even though it was kind of panicky, because she had once again come across sodium tripolyphosphate, but this time it was on a different label. And I suspect some of you, especially mothers who have young children, may recognize what this label is. This is this magical commodity called Kraft Dinner. So she says to me, you know, I give my son Kraft Dinner every day, which apparently was not a problem. What is a cleaning agent doing in there? So again, I launched into my discussion saying that, look, polyphosphate is actually a multi-talented chemical. It can do many things. In the case of cleaning agents, it can enhance the work of the detergent, but here it is doing something else. It is enhancing the absorption of water by the starch in the macaroni, so that when your son starts to clamor for his daily allotment of Kraft Dinner, you can deliver the goods more quickly. And then I went on to say, look, phosphates occur in nature. You take a bite of food, it has more naturally occurring phosphate that you get in a dozen boxes of Kraft Dinner. I don't know if she bought the argument this time, because for her, chemicals were all right in cleaning agents, but not in food. Perhaps she thought that the Kraft company, knowing that eating their products can be a messy business, decided to increase sales by providing some means that the kit could be cleaned from the inside out. Well, where do they get such ideas? From reading books like this, A Consumer's Dictionary of Food Additives by Ruth Winter. I don't know this lady, but she has no business writing such a book. How do I dare say that? For several reasons. One, I think the chance that she's watching this recording is remote. But much more important than that, I can back it up scientifically. Because if my phosphate-fearing friend looked up in this book, she would find cuticle softeners, shampoos, bubble baths, bath salts, all of that makes sense for a cleaning agent. But looking a little bit further down, also in incendiary bombs and in tracer bullets. Now she would not only worry about her son being cleaned from the inside out, but she'd be concerned about him bursting into flames and disappearing, albeit not without a trace. Ruth Winter had made the most fundamental of all chemical errors here, confusing phosphorus, the element, with phosphate. Once phosphorus combines with oxygen to form phosphate, it is a totally different substance. This is tantamount to saying that you better not drink any water because it contains hydrogen. And remember the explosion of the Hindenburg? That was hydrogen. Well, there's a big difference between hydrogen gas or hydrogen bonded to oxygen, as in water, makes a totally different substance. So this is why I say that she has no business writing such a book, because if you make such a fundamental chemical error, how can anything else be trusted? Now, she is not the only one out there promoting this kind of misinformation. The Food Babe is another one. And she has amassed a large following on the internet with this name she anointed for herself. Vani Hari is her real name. And she has no scientific background. But these days, you don't need scientific background. You just need something catchy to get an audience. Her catchphrase was, "You wouldn't eat a yoga mat, would you?" Where does this come from? She attacked Subway, which is now the largest fast food company in the world, because they were using a chemical called azodicarbonamide in their buns. And she had a hard time pronouncing this, so therefore it must be dangerous. I guess she must have looked up something in the literature and discovered that when rodents were fed gigantic doses of this, there were some problems. Well, azodicarbonamide with heat breaks down to release nitrogen gas. And that can be a leavening agent, just like carbon dioxide. When you use yeast, carbon dioxide is released, and that's what causes the bread to rise. Well, you can also use azodicarbonamide. It's an approved food additive. It has been well tested, but she didn't like it because it was, quote, a chemical. She didn't want it in their Subway buns. Why? Because the same chemical is used in yoga mats. Well, yoga mats are made of plastic that is foamed. Foam just means that it has gas bubbles in it. How do you make those gas bubbles? One way is to use azyl dicarbonamide to release nitrogen gas, and nitrogen, of course, is not a problem. It makes up 80% of the atmosphere. But she got people thinking that when they're eating at Subway, they're actually dining on yoga mats, and that there are some, uncaring food suppliers who are loading up their products with this dastardly chemical. She even went on all of the talk shows dramatically eating yoga mats. Of course, it made no sense whatsoever because she was talking about the villainy of the chemical that was used to make them. But nevertheless, the public paid attention. Subway gave in, and they removed this chemical from their product. Now, there's nothing wrong with removing it because obviously you can make bread without this. That's been done for millennia. But here was a situation where there was no science to back up why this had to be removed. The fact is that just because something is commonly used in food doesn't, in some non-food connection, doesn't mean that it cannot be used in food. Just because we wash our garage floors with water doesn't mean that we can't drink water. Just because we make our gravestones with calcium carbonate doesn't mean that calcium carbonate in Tums pills is a problem. We always have to search for evidence and look at the risk-benefit ratio of any kind of substance or process that we are concerned about. We actually spend our life evaluating risk, don't we? Not consciously, of course, subconsciously. You get into your car, you don't think that there's a risk, but of course there is. But subconsciously, you made the decision that the benefits outweigh the risk. Now, in the realm of science, we base our risk analysis on what we know as the peer-reviewed literature. A researcher carries out study, writes it up, sends it into the editor of a journal, who then sends it out to some reviewers, we call them referees, who will eventually determine if the work is good enough to be published or not. There's often a lot of back and forth. They may ask for more information, and eventually it gets published. It is a great safeguard against wrong information, but it's not foolproof. For example, that terrible paper by Andrew Wakefield that connected the measles, mumps, rubella vaccine to autism was published in The Lancet, one of the world's premier journals. How did that happen? Because if you're asked to review a paper, you of course have to assume that whatever data was submitted was legitimately gathered and the studies were properly done. Because a referee obviously cannot redo the work. Work usually is, the work of a couple of years by several people. So you have to assume that what was submitted is legitimate. If someone is going to submit fraudulent data, as Wakefield did, then obviously you're not going to catch it until someone tries to duplicate the work. But that can take years. In this case, it was about 20 years. And by that time, we were having epidemics of measles that we hadn't seen for many, many decades. Why? Because people were acting emotionally, not scientifically. And unfortunately, emotion often beats science. That's one of the big problems that we face. I'll give you a quick example of this, a real example. Not long ago, a group of ladies was playing golf in a course just outside of Montreal. And they were out early in the morning, and a truck comes by, and they felt a spray. They rushed back into the clubhouse, and they accosted the greenkeeper because they felt that they had been exposed to some toxin. One of them complained that she got a headache. The other one got a rash. Third one had the biggest problem of all. But I'm sure by now you guessed the bottom line to the story. There was a truck out spraying early in the morning. Spraying what? Spraying water. But because these ladies had heard about and read about all of the potential problems that can be due to exposure to pesticides, they assumed that pesticides were being sprayed, and then they experienced symptoms. Now, the symptoms they experienced were real, but they were generated by the mind. This is what we call the Nocebo Effect, which is sort of the bad cousin of the placebo effect. If you think something can be harmful to you, it can be. people believe, for example, that an artificial sweetener like aspartame gives you a headache, they will get a headache. It's a very interesting thing, the body-mind connection. And that connection can be beneficial or it can be detrimental. Well, talking about this business of evaluating risk, let me hit upon a very specific example, and one that you've probably read about because it is a chemical that's been in the news extensively. And this is glyphosate, which you probably know as Roundup. And Roundup is the world's most widely used herbicide or weed killer. It is used in agriculture extensively, especially on genetically modified crops, on soy, on alfalfa, corn, and on canola, because those crops have been genetically modified to resist glyphosate, meaning that you can grow your crop, spray the field, kill the weeds, and weeds, of course, are the classic enemy of the farmer because they soak up nutrients from the soil. You kill the weeds without harming the crop. I mean, obviously, this is greatly beneficial to the farmer because yields will be increased and profits obviously will be increased. But it's also beneficial to the consumer because it means that more food is available at a lower cost. Now, there, of course, are all kinds of concerns about glyphosate because, let's face it, it is a legitimate weed killer. So if it kills weeds, what else might it do? And obviously, that's a legitimate question to ask. But before any pesticide gets put on the market, it has to jump through all kinds of regulatory hoops and hurdles before it is allowed. It's not a question of, some chemical company thinking, well, we think that this might work, so we're going to market it. That's not how it works. Of course, you can never guarantee anything to be 100% safe, whether it's a pesticide, whether it's a drug, or whether it's a food component. People can have intolerances, allergic reactions, etc. But glyphosate is as safe as one can, determine it to be. And yet it has been painted to be a villain by alarmists who will sometimes bring out a visual like this, where they will show you that there has been an increase in autism paralleled by an increase in glyphosate. Well, this is one of the most fundamental errors that can be made, and it is usually made by people, obviously, who have no background in science. Just because two measurements run in parallel doesn't mean that they are linked. To give you the classic example, I could also draw a graph between linking autism and sales of organic food, because these have increased in parallel also. But there is obviously no link here. I mean, no one in their right mind would suggest that organic foods cause autism. And yet, the exact same argument is being used for glyphosate being linked to autism. The fact is that correlation is not the same as causation. Association can never be termed causation, and association can be a springboard for further research. Now, why is there so much concern about glyphosate? Because the International Agency for Research on Cancer, IARC, which is an arm of the United Nations, has placed glyphosate in the probable carcinogen group. Now, IARC has classifications, as you can see here. And group 1 is things that are known to be carcinogenic, like asbestos, tobacco smoke, etc. And group 2A is probably carcinogenic. So that raises some eyebrows, and this is where glyphosate has been put. However, here is a critical point to make. The IR classification is based on hazard, not on risk. And although those two words in the lay press are often used interchangeably, scientifically, they are certainly not interchangeable. There is a relationship between them. Risk is a function of hazard, but you have to take into account exposure. Hazard is an innate property of matter or of some process. It cannot be changed. You cannot change smoke in a cigarette from the havoc that it can cause. That's what smoke does. But you can reduce risk by reducing exposure. Let me give you an example. Take a grizzly bear. I think we would all agree that this is a hazard. This is one of the most powerful animals in the world. A swipe of its paw can take off a human head. No question that it is hazardous. But that hazard cannot be changed. That's a property of this creature. However, if you are viewing it in a zoo, your risk is minimal because you're separated by a barrier. However, if you're out in the wild and you should encounter a grizzly, you better start running, and running fast, or at least faster than one of your friends, because now you have a real risk. Your exposure is quite significant. So when glyphosate is put into category 2A as a probable carcinogen, it is based on the fact that in some study, in huge doses in some animal, it caused a problem. It means it has the potential to do that. Not that it does so in the doses that we encounter. I'll also remind you that in the same category as glyphosate are hot beverages, because if you drink very hot beverages often, it can lead to cancer of the esophagus. Of course, it's a remote possibility because we don't drink boiling hot beverages. Similarly, barbecued meats are in the same category as glyphosate, because when you heat the meat to high temperature, it forms compounds like heterocyclic aromatic amines, which are known carcinogens. Or when you bake bread, believe it or not, the bread is in the same category, because when you bake it, the high temperature causes glucose in the batter to combine with an amino acid called asparagine, and that forms acrylamide, which is a known carcinogen. Or if you happen to work in the hairdressing business, well, you're also in group 2A because of all the substances to which you are exposed. But interestingly enough, in group 1, known carcinogen is bacon, which is the fastest growing food in North America. That's in group 1, not in group 2A. Also in group 1 is alcohol, because it is a known carcinogen. There's no question that alcohol is linked with cancer of the mouth, cancer of the esophagus, and also breast cancer. So the fact that glyphosate is a hazard doesn't mean anything until we can determine risk, which is based on exposure. And then we have to know what our exposure is. But we can determine that because we can measure amounts in the urine, which is, of course, a measure to what we are exposed. If it comes out in the urine, it got into the body somehow. So we have exposure. So what do the numbers here tell us? The acceptable daily intake of glyphosate is 0.5 milligram per kilogram of body weight. This comes out of a lot of human epidemiological studies, animal studies, laboratory studies. And at that dose, if you were to take it in every day, there would be no harm. Now, if you were taking in that dose every day, you would expect to see about 4 milligrams in every liter of urine. But what do we actually find? 1 to 3 micrograms in the general population in North America. That is 1/1300th of the acceptable daily intake. That's far from any potential toxic dose. Thing is that in toxicity, any study of toxins, numbers matter. Science revolves around numbers. Whenever we talk about hazard or risk, numbers have to get involved. You've heard the expression, only the dose makes the poison, first voiced by Paracelsus over 500 years ago. And that, of course, is the cornerstone of toxicology. We cannot have any kind of risk assessment without numbers, without knowing dose, because it can be very misleading. I'll give you an example of this. I think most of us would agree that an apple is a healthy food to eat. But you know what you're getting when you bite into an apple? This. Now, these are not additives. These are not pesticide residues. These are the building blocks of the apple. That's what it's made of, including acetone. Well, the last time you met acetone, it was probably on the label of your nail polish remover, right above where it says, do not drink. Very good advice, because acetone can be highly toxic. But also in that apple, you have formaldehyde. You know what that is? That's the fluid used by embalmers to preserve bodies. Formaldehyde is highly toxic. In fact, it's carcinogenic. So acetone can kill you. So can formaldehyde. However, it's an economical way to go because you'll be pre-embalmed. If that strikes you the wrong way, if it rubs you the wrong way, well, there's some rubbing alcohol in there as well. So I could tell you a story and come to the conclusion that that apple is actually trying to take a bite out of us. Of course, this would be absurd, even though everything that I just told you is true. The apple contains formaldehyde, it contains acetone, it contains isopropyl alcohol. But the doses are so small that they are inconsequential. They are masked by all the good vitamins, minerals, and various kinds of antioxidants that are found in the apple. So the moral of this little story is that the presence of a chemical does not equal the presence of risk. Just because you find something doesn't mean it's harmful. And these days we find things easily because we have sophisticated equipment. We have our gas chromatographs, our mass spectrometers. Today, we can find substances down to the part per trillion level. To give you an idea what that is the width of a credit card relative to the distance between the Earth and the moon. That is 1 part per trillion. We can find that. That's not a needle in a haystack. That's a needle in a world full of haystacks. And given that there might be 1 needle in 1 haystack somewhere in the world, would that prevent you from a good old-fashioned roll in the hay? I think not, because you would judge the benefits outweigh the risks. The fact is that life is full of risks, all kinds of risks. There are some real risks that people will take, but then there are also the phantom risks that people may worry about, which are not real. Risks are everywhere. You can be out for a casual walk, and unfortunately, terrible things can happen. Oh, but don't worry, we're nice people, we faked it, they're fine. But they are not the innocent little creatures that you think they are. There's a risk with everything. Now, it turns out that people are willing to take risks when they know what that risk is and they have agreed to that risk. What they are not willing to do is be exposed to risk when they have not made any decision about it. So of course they worry about pesticide residues in food because they have not agreed to those being present. However, just because they're present doesn't mean that they're harmful. It's always a question of risk against benefit. And furthermore, when we decide that there's a risk with something and we decide to replace it, like if we were going to replace bisphenol A with some other chemical, you have to make sure that what we're replacing it with is safer, because you don't want to go from the frying pan into the fire. So let me again just review this very important point, because I think this is critical, that the presence of a chemical does not equal the presence of risk. Risk evaluation is a very tough business. You have to know the hazard of a substance and you have to know the exposure. And just because you're exposed doesn't mean that there's a problem. There are a few other points that I would like to leave you with to keep in mind. The effect of a substance depends on what it is, on its molecular structure, not on whether it came from a plant or was made in a lab. Whether a particular substance is made by a chemist in a lab or by Mother Nature in a bush makes no difference. What matters is what that substance is and what we have learned about it. There are numerous natural toxins. Botulin, produced by the Botulinum clostridium bacterium, is the most toxic substance we know. Ricin, produced by castor beans, is natural. Poison ivy is natural. Scorpion venom is natural. The COVID virus is natural. We spend our life trying to overcome the ravages of nature. Another important point, though, to keep in mind is that children are not small adults. And substances that are perfectly safe in adults may not be safe in children when the nervous system is being formed. Furthermore, humans are not giant rats, although there are some exceptions to that. So we cannot always extrapolate the high-dose animal studies that we carry out to humans. Unfortunately, we usually cannot do the relevant studies to humans because you cannot expose people on purpose to toxic substances. But just because something is a problem in an animal doesn't mean it's going to be a problem in people. That takes extensive investigation. And furthermore, even closely related animals may behave differently. For example, dioxin, one of the most toxic substances in existence. It's never made on purpose. It's always the undesired byproduct of some industrial process. Terribly toxic if you're a guinea pig. But if you're a hamster, you can practically frolic in it. Or consider chocolate. Imagine it didn't exist. I know it's a painful notion, but imagine that. And one decided to test it before putting it on the market. And instead of using rats, you were going to use dogs. Well, we would never have chocolate because dogs cannot handle theobromine, which is a component of chocolate. We, of course, can. And we do. We eat chocolate without any kind of a problem. Remember also that no matter what, science can never prove that there's not a risk associated with some chemical. You cannot prove a negative. I couldn't even prove to you that reindeer cannot fly. I don't think they can, but I don't think I could prove it. I could take one top of a tall building and nudge it off, and let's face it, if that animal ever in its life were motivated to fly, that's the moment. I could repeat it with the same results. What would it have proven? That those reindeer today could not, or for some reason chose not to fly. But maybe there are some reindeer, maybe 8 reindeer, that under the right conditions, under the right simulation, the right weather, maybe they can fly. So you can never prove a negative. Keep in mind also that there are always opposing views in science, no matter what. Look at climate change. Yes, there are deniers, but 97% of all atmospheric chemists agree that climate change is real and that humans are a causative factor. Unfortunately, journalists, when they write controversial articles, will interview a person from both sides, and they will write an article, and it seems like the opinions are of equal weight. There may be controversies, but they're divergent. They're not of equal weight. In the case of climate change, there's 97% agreement among scientists that it is real. But these days, there's so much stuff being published that you can basically back up everything by cherry picking data. But in real science, we don't cherry pick. We shake that whole tree. We mash those cherries, and then we give it a taste. And then we come to a conclusion on facts, not on anecdotes. Just because your neighbor may have taken some homeopathic remedy and got better doesn't mean that the remedy works. Science, in fact, is not a collection of unalterable truth. We change our mind when evidence makes us change it. The accusation against Dr. Fauci, of course, that he changed his mind. That's not a bad thing, that's a good thing. Because at first, when the information about masks was what it was, the interpretation was that they don't make much difference. But as data began to be gathered, we learned a lot about it. So of course you changed your mind. It's only the pseudoscientists, the quacks, who never change their minds. They will keep plugging away at whatever silly belief that they have. We can never predict all consequences of our actions. Who could have predicted back in the 1930s, when in refrigerators we replaced sulfur dioxide and ammonia, which were terrible because if you had a leak in your kitchen, it could be, it could kill you. Replace them with Freon, totally inert, great in refrigerators. Who could have ever predicted that 50 years in the future, we would find Freon in the upper atmosphere destroying the ozone layer? How could you have even thought of that? Today, however, we can think of such things because we have a much bigger scientific basis. We're less likely to make mistakes. All because we know a lot about chemistry. And so I come back to that point. And I think that chemistry is of great help in trying to solve the problems today, but it cannot solve all problems. But I leave you with one last story. My previous book, the one before the one that was just published now, was A Grain of Salt. And you can imagine what that is about and how you have to take a lot of the information that you get with a grain of salt. And just after it was published, about a week later, I get a call from the publisher. Says, you know what? Great news. Your book is on the bestseller list. So good, just after a week, that's great. So I look at the bestseller list, and indeed, there it is. I was at number 9, pretty good. But then I start looking up the list. And what do I find? I find a book by Anthony William, who calls himself the medical medium. And he gets his advice from the spirit world. He has a spirit doctor that he consults. He actually has a radio show in Florida. People call in with their problems. He gives them answers from the spirit world. That protects him from being accused of practicing medicine without a license, because the advice is not coming from him, it's coming from spirit. You can get away with such nonsense. The spirit always says, drink celery juice. That seems to be the answer to everything. So I was kind of, diffused with my happiness about being on that bestseller list when you see nonsense like this being higher up. So today, more than ever, it is imperative to separate sense from nonsense, as difficult as that may be. And I suspect that what we've chatted about here today would bring up some questions, but I'll tell you that unfortunately, science does not have the answer always. There are some questions that no matter what, we will never have an answer to. But should you have any questions further down the road, you can always take a look at our website. And there are thousands of articles there, thousands of all kinds of interesting things. You can sign up for our free weekly newsletter. Comes to you every Saturday morning, informative and entertaining. I'm pretty sure that that's what it is. If you have any questions, you can always email me. There it is. And I'd certainly be happy to try to answer any questions that you might have now. So let me just check in to see whether or not.
That.
Okay.
One of the questions is, Doctor, are all alcohols equally bad? You mentioned alcohol. So is wine,
Yes.
for example, better than
vodka? Well, it's of course, it's a question of dose, right? And the amount of alcohol that you'll get in a shot of whiskey is more than you'll get in a glass of wine. But yes, I mean, unfortunately, and I say, unfortunately, because, people like at least small amounts of alcohol. It's one of the spices of life. Is that when you look at all the studies about alcohol, there seems to be no threshold effect. That is, we can't say that, below a certain amount, there's absolutely no risk. On the other hand, that being said, I think we also have to be realistic in the sense that you can't and shouldn't evaluate every morsel of food you put into your mouth and every drop of drink as, is this good for me or not? Life is about more than that. And life is here to be enjoyed. You get one shot at it, or at least so we think. So really, moderation is the answer. And I would not tell someone who enjoys, that glass of wine not to drink it. Yes. On the other hand, someone who doesn't drink wine, I would not tell them to start.
Right, I understand. We have another question. Are there any good YouTube channels or presenters that the public can trust and for sources on nutrition or supplements?
Good question. I would say that science-based medicine is an absolutely spectacular site, science-based medicine. And FDA, of course, has a very, very good site. Health Canada has a very good site. And I would hope that our website falls into that category.
Would you tell the guests exactly what do they Google to find your website, or do they just Google Dr. Joe, or what is it that they?
www.mcgill.ca/OSS.
Thank you. Thank you. Because they would not have, I know that you're at McGill, but they would not have known that.
Yeah.
And finally, what are you working on for your next book, sir, so that we can look forward to it?
Well, this one, of course, had a good dose of COVID in it. I hope the next one doesn't have to have that. I hope that we'll be able to climb out of this dark hole. But all my books have kind of the same themes, you know, stories that I come across, which I think are interesting, you know, based on questions that I get on my radio show or questions that I get from students. So I kind of think that I have my fingers on the pulse of, you know, of the public and what they're interested in. So there are always sections in my books on food, on cosmetics, on drugs, on the environment. And so I can't say exactly what the next one will be about. It depends on, you know, what sort of things come up.
And I see one more popped up from Inger Wood. She would like to know, with journals and magazines, what are some scientific or medical groups that would be trustworthy? You kind of answered that, but
yes, well, I mean, obviously, the most trustworthy ones are the peer-reviewed scientific journals, like, you know, New England Journal of Medicine, the Lancet, the Journal of the American Medical Society, Journal of the American Chemical Association. However, those are not light reading for the general public. For the general public, I think the best publication out there is a British publication called New Scientist. It's very readable, and it covers basically all areas of interest. Discover magazine is also very, very good. So I would say that if you have just one to select, it would be New Scientist, because it covers such a wide range of topics. If you want more in-depth, then the Discover magazine, which is also very good. But, you know, once again, I mean, I don't want to be too self-promotional here, but we have thousands of articles on our website that are you know, that basically address every topic that you might, you know, it's very easy. So it's www.cjad.com. And my show is on Sundays at 3 Eastern time. So that's same as your time. So, and anyone can listen, but also if you go to our website, all the shows are recorded. So you can listen there as well as podcasts.
well, thank you very much. This talk was just awesome. You add so much humor to the practical advice you give us. And a lot of us probably feel very, because we don't know what to believe and what not to believe.
See, the trouble when you do a talk on Zoom and you make a joke, you don't know if it goes across or not.
It goes across. You're very good. I think it's why your books are so darn popular. So everybody, we remind you again, this is the newest book, Science Goes Viral, captivating accounts of science in everyday life. We thank you for coming to us, Dr. Joe from Quebec, and we thank our guests here in Gwinnett County and look forward to the next book, Dr. Joe. Thank you so much.
Thank you very much.